Take our next topic, central limit theorem. Next topic, central limit theorem. Central limit theorem. Here we will be discussing three different forms of the theorem. Only the statement is enough, no need to study the proof. Okay. So already I discussed so many things. Why the central limit theorem is necessary. Okay. So in unit 1 we discussed about the one-dimensional random variable. In unit 2 and 3 we are discussing about unit 3 and we are discussing about two-dimensional random variable. If the number of variables is good, okay, then we can take the central limit theorem to discuss the problems. Okay, while the unit 1 what we can find probability of x greater than 2. We will find that one here in unit 1. Unit 3 what you can find probability of x is equal to 0, y equal to 1. Combination of two variables. If suppose you are supposed to find what is probability of x plus y plus z etc. equal to some values. Okay, more than two variables. Then you can take the help of the central limit theorem. Okay, we are not going to discuss in very deep, just some generalized problems only we are going to discuss. But there are three different forms. Okay. So from the question you have to identify which form of central limit theorem you have to apply to solve the problem. Okay, that is the one thing you have to identify. That is also easy. I will tell you how to identify. Okay, so take the first form of central limit theorem, Lindbergh's-Levy form. That is the name of the mathematician who gave this theorem. Lindbergh-Levy's form. Lindbergh-Levy's form. That is the first one you are going to discuss. So take out the statement. If x1, x2, etc. up to xn, if x1, x2, etc. up to xn, yes, a sequence of independent, identically distributed random variables, with expectation of xi is equal to mu and variance of xi equal to sigma square. Expectation of xi equal to mu and variance of xi equal to sigma square, where I equal to 1 to etc. up to n. I equal to 1 to etc. up to n. And if Sn is equal to x1 plus x2 plus etc. up to xn, Sn equal to x1, x2, etc. up to xn, comma, then under general conditions, Sn follows a normal distribution. Sn follows a normal distribution with mean nu and variance n sigma square, mean n into mu and variance n sigma square as n tends to minus mean divided by standard deviation. So here what we are going to do is that whatever data is given, you are going to find Z. Then using our normal distribution, you are going to find the probability value. That's all the problem. Okay. For which problem, what Z you have to write as the only thing you have to remember. Okay. Here what is the condition? It is independent and identically distributed. So you are given the mean as NU and the second one is variance of standard deviation. Variance is going to be N sigma square. If you are going to discuss the problem with this one, our Z will be x minus mean. What is the mean value? NU. Divided by standard deviation. This is variance. So what is standard deviation? Square root of this one. So we take square root, what you will get? Sigma into root. So this is the exact formula I make use of when you solve by regular. Okay, got it out. If you are going to apply a regular constant test, this is the exact formula. So here it is identically distributed now. So everything is going to have the same mean and the variance. Okay, next one, Lipinow's form. Lipinow's form of central equilibrium. Second one. What do you do that? Lipinow's form. Take a statement. If x1, x2, etc. is right now, if x1, x2, etc. be a sequence of independent random variables. Be a sequence of independent random variables with expectation of xi is equal to mu I. Expectation of xi is equal to mu I and variance of xi equal to sigma I square. And if Sn is equal to x1 plus x2 plus etc. plus xn. Sn is equal to x1 plus x2 plus etc. plus xn. Then under certain conditions, Sn follows. Under certain conditions, Sn follows normal distribution with mean mu equal to summation I equal to 1 to n mu I, summation of all the mean values, and variance sigma square equal to summation I equal to 1 to n sigma What we have discussed so far. Population mean is mu. What is the sample mean? X bar. Sample mean denoted by X bar. So in this parallel we are going to discuss how to find the probability value for X bar. 90% problems will be coming under this parallel. Okay, so we know if X bar is equal to X bar is equal to of 60 bulbs, average lifetime of 60 bulbs exceed 1250 hours. Exceed 1250 hours. Take a statement. What is given? We are discussing about the lifetime of an electric bulb. What is the mean value given? 1100. What is the notation for mean? Mu. So you are given that mu equal to 1100. What is the next one given? Standard deviation. Notation same. So sigma equal to 250 hours. What you are supposed to find? Find the probability that the average lifetime of 60 bulbs. What is the 60? Notation. Total number of bulbs. After what is the notation for that one? N. Total number. So what is the notation? N. We are given N. Now we identify clearly what you are supposed to find. Find the probability that the average lifetime. Average means what is the minimum? Average no? Mean. Okay, mean of how many bulbs? 60 bulbs. Okay, so we are supposed to find the probability for X bar. Okay, because we are also find for the average lifetime. Previously we discussed what is the for the X variable. But here what is supposed to find? Average. Okay, so you have to find what is the probability of average lifetime. Average lifetime is X bar exceed 1250. Exceed means what is the notation? Exceed. Mathematical notation. Greater than or less than or equal to. Exceed. Greater than. Exceed means what is the meaning? More than. So more than means what is the symbol? Greater than. Greater than 1250. This is what we are supposed to find. Okay, that last line is the important one. Find the probability of the average lifetime. So we are going to find it for X bar. Can you find this from any general formula? Any general formula that you know you are going to make any specific result? General formula. What is the formula? X minus M. That is for X. Here you are trying to find for X bar. Others? And the corolla and corolla formula. In corolla which variable are discussed? X bar. In corolla we are discussing only for X bar. In your question you are supposed to find the probability for the average. X bar means we are taking help of that corolla. So we are going to take the help of our central limit theorem to solve this problem. Okay, so even if they don't mention central limit theorem in the question, we are identified. Okay, nowhere else, no other formulas is there to find for average lifetime. Find the probability of average lifetime is only possibility is the central limit theorem, no other choices are there. Okay, so right, by central limit theorem, have you written this one all the terms of notations? Everyone written? So right, by central limit theorem, X bar follows normal distribution with mean mu and standard deviation sigma by root. Remember this one thoroughly. So how many factor is there? Is there equal to X of X we are having X bar. So X bar minus mean is mu. Divided by standard deviation is sigma by root. This is the formula to find your result. So what is the X bar value here? 1250. Substitute and find what is the corresponding exact value. So 1250 minus mean is 1200 divided by sigma value is 250 divided by square root of 10. So square root of 60. Find what is this? The same normal distribution concept. Two values. For both of this, you define what is the you remember how is tables are right now? Not only. Both the profile values. Normal table is defined only for which values? 0 to z. You rewrite these two values from 0. So you can write this one as probability of 0 less than equal to z less than equal to 3.45 plus probability of 0 less than equal to z less than equal to 0.82. Because normal tables are defined only from 0 to z. So using normal table you get it answer to be 0.7863. 0.